heart went.
Our second method, the Sarrus method or the rule of Sarrus or Sarrus's rule, which is also known as your basket weave method or yung basket method natin ng high school, in which we apply on third order matrices only. So for a 3x3 matrix B, for example, with its entries as follows, so ito na yung entries natin. Para daw makuha natin yung determinant using the Sarrus method, you are going to copy the first two columns to the right of the original matrix, thus creating a 3x5 matrix. So, you're going to copy the original matrix. So, ito pa rin yung nasa taas. And then, to the right of this, ito yon sa kanan yan, kokopyahin mo daw yung first two columns. Okay, after copying for the first two columns, proceed with the basket weave method by calculating the sum of the products of the entries in the downward diagonals and then subtracting the sum of the products of the entries in the upward diagonal. So, after mo makreate yung 3x5 matrix natin, kukunin mo yung product ng downward diagonals natin. So, that would be yung B11, B22, B33, mumultiply mo, kaya ito yon. So, pag downward daw, yung ating diagonal, that will bear positive sign. Okay, yun yung madaling tandaan. So, you have B12, B23, B31, and then B13, B21, B32. Lahat ito positive. They will bear positive signs. And then, lahat naman ng upper pataas na diagonal natin will bear negative signs naman. So, yung B31, B22, B13, that will bear a negative sign. And then, you have B32, B23, B11, negative din yun. And then, B33, B21, B11, negative din yun. So, as you can see here, ang ginawa ko na lang ay lahat ng downward diagonals minus yung sum ng lahat ng upward diagonals. Para, di ba parang ganun din? Pag dinistribute mo yung negative sign, negative din yung upward diagonals natin. Okay, so I've discussed Sarrus rule on our PowerPoint presentation, but I want us to compare it to Leibniz formula. So for that, alam natin Sarrus is also known as basket method or your basket weave method. Okay, so para hindi tayo mahirapan mag-compare, okay, I'm going to use the determinant of matrix A, which contains the same entries as the entries we used kanina when we solved for 3x3 determinant using Leibniz. So, for Sarrus rule, ang sabi doon sa ating discussion, kailangan nyo lang daw kopyahin ulit yung array natin. So, A, B, C, D, E, F, G, H, I. And then after these three columns, copy the first two columns of the original determinant. So I'll have here A, B, D, E, and then G, H. Afterwards, get all the 3 entry diagonals. Yung mga diagonals na may tatlong entry na laman. So that would be A, E, I. So meron tayong, paano ba to? Downward diagonals. We have downward diagonals here, A, E, I, B, F, G, and C, D, H. All the downward diagonals will obtain a positive sign. And then, you also have 3 entry diagonals upward. So, you have G, E, C, H, F, A, and I, D, B. Lahat naman ng upward diagonals will be negative naman yung sign nila. So, if we're going to write that down and enumerate all the products that we have, you'll have A, E, I, positive yan, plus B, F, G, which is also positive, plus C, D, H, which is also positive. Tapos, magne-negative yung sign ni G, E, C, minus G, E, C, minus H, F, A, minus I, D, B. And then, let's compare this with the Leibniz formula that we've had kanina. So, pop, eto na yon. So, yung Leibniz natin has AEI positive, which is correct. Then you have AFH is negative. Ito din yun, di ba? Nagpalit lang ng position yung factors natin. Okay, and then BFG is positive. BDI is negative. BDI, ito yun. CDH is positive. CEG is negative. So, ito yung sinasabi ko sa inyo, class, na as time goes by, there are different methods na discover na nag-create siya ng same solution lang din. Diba? Same solution ito. I mean, same yung notations ng solution natin, but they were obtained on different methods. So, if you're going to compare Sarrus na 3x3 dun sa Leibniz na 3x3, mas madali itong gawin compared to this one. Kasi dito, kailangan pa natin mag-isip ng permutations eh. So, it's easier. Okay? Kaya, ang dami pong methods available at magkakaiba yung mga tawag. Kaya, ang hirap i-compile nila lahat. So, let's have an example that will use Sarrus rule or basket weave method. So, remember po how we only use this method if it's 3x3. If it's not 3x3, don't use this. Hindi siya applicable. Okay, let's say our determinant of A is equal to the determinant of the elements. Let's say 5, negative 15, 10, negative 1, 0, 4. Let's say we have 8, 10, 2. Okay. So, with the presence of our calculator, di ba hindi tayo nangangamba kahit pa malalaki yung digits ng entries natin because we do have the calculator. But for the purpose of incorporating the properties, di i-apply natin just so to make use of them. Okay? So, in the first row, you can notice all of these are multiples of 5. So, I can factor out 5 from every element on the first row. And if that happens, please be patient on the manoks that we have outside. Okay. I'll factor out 5 on all the elements or entries in the first row. That would be 1, negative 3, positive 2. And then the remaining ones will remain the same. No change at all. Tatandaan nyo yun ha, magkaiba po ang factoring from a determinant and from a matrix. Okay, next, what else did we notice? I noticed these elements are all multiples of 2. Ganun din to. So, isa-isa lang. Okay. Unahin natin to. So, we have 5 times. You have 1, negative 3, 2. And then negative 1, 0, 4. And then I factor out 2 from here. That would be 4, 5, and 1. So, after factoring out 2, you'll have 2 multiplied to the determinant. Okay. But in this case, after factoring out 2, hindi na to multiples of 2. So, wala na akong makitang multiples. Therefore, that would be 10 multiplied by the determinant of 1, negative 3, 2, negative 1, 0, 4, and 4, 5, 1. Now, let's apply Sarrus on this 3x3. Okay, let's make a space here sa taas. Okay, let's apply Sarrus rule for this 3x3 determinant. That would be 10 multiplied by, kokopyahin ko yung original, determinant, negative 1, 0, 4, and 4, 5, 1. And then after this, copy the first two columns, 1, negative 1, 4, and negative 3, 0, 5. And then proceed with the basket weave method, diagonal multiplications. So we will have 10 multiplied to all our answer. So, ano yun? Let's start with the downward diagonals. Diba? Which will obtain positive signs. So, let ito positive. Therefore, you have positive 1, 0, and 1. Plus, you have negative 3, positive 4, positive 4. And then, plus 2 times negative 1 times 5. And then, we'll proceed with upward diagonals naman that will obtain negative signs or negative 1. Okay. Or subtract. Simply subtract all upward diagonals. That would be 4 times 0 times 2 minus 5 times 4 times 1 minus 1 times negative 1 times negative 3. Okay? So, let's simplify that. That would be 0 plus 16 times negative 3, that's negative 48. And then, negative, this is 10. This one would be minus 0. This is negative 20. Wow, 20. Minus negative 1 times negative 3, positive 3. So, minus positive 3. Yan. Okay. That would be 10 times, how much? Negative 48, negative 58, negative 78, negative 81. And our answer will be negative 810. So that would be the determinant using the basket weave method or the rule of Sarrus. So why do we have to show you the manual solving of the determinant? Siyempre, tinatanong pa ba yun? Because your calculator is not applicable for functions. Kung ito yung mga given, pwede ka mag-calculate, you can use Excel. But, if you're using variables, you have complex numbers here, your calculator cannot do that. So, you have to have the skill of solving it manually or conventionally. Especially if, sa EE, diba, sa power systems, ito yung gagamitin nyo. So, kailangan marunong. Okay?